For this investigation, we're looking at another special right triangle. This is a 30, 60, 90 triangle. But first we're going to start with an equilateral triangle. Remember, equilateral triangles have all sides that are the same length, and they're also equiangular. So we have here an equilateral triangle. All sides are 4 centimeters. And here we have the altitude. Now, this is also an isosceles triangle. So what we've done with that is we've bisected this angle, which means each of these angles are 30 degrees. And we've also cut this side in half. So these would be congruent to each other. So now we have a 30, 60, 90 triangle on each side. Now with that 30, 60, 90 triangle, here we have the hypotenuse, which is 4 centimeters, which means that the side opposite the 30 degree angle, which we're going to call the short leg, will always be half of the hypotenuse. And we can see why when we look back at our equilateral triangle. The short leg is always half the hypotenuse, so it's going to be 2 centimeters. Now we can use Pythagorean theorem to find what we will refer to as the long leg. The long leg is always opposite the 60 degree angle. So if we use Pythagorean theorem, we could say 2 squared plus b squared is equal to 4 squared. And now we solve for b. Okay, so when we're solving for b, we've taken 2 squared is 4, and 4 squared is 16. We're going to subtract that to this other side, so b squared is equal to 12. When we take the square root of 12, remember to keep your answer in simple radical form, we end up with our long leg being 2 square root 3 centimeters. Now the first thing we want to do with any 30, 60, 90 triangle is identify short leg, long leg, and hypotenuse. Remember, the short leg is always opposite the 30 degree angle, the long leg is always opposite the 60 degree angle, and the hypotenuse, of course, is always opposite the right angle. So if we're given the short leg is 5, then we would know that the hypotenuse would have to be double that. So the hypotenuse is 10. Now we can use Pythagorean theorem to find the long leg. So we have 5 squared plus b squared equals 10 squared. And now we solve for b. So now we've solved for b. We see 25 plus b squared equals 100. B squared is equal to 75. When we take the square root of 75 to keep our answer in simple radical form, we have 25 times 3, which gives us 5 square root 3 for segment B. Seems like we have a pattern here. If we have a 30, 60, 90 triangle, and we know that the short leg is x, and the hypotenuse then would be double that, so that would be 2x. And the long leg would be that same value as the short leg times the square root of 3. So if we have a short leg of 8 on this triangle, how can we find the long leg and how can we find the hypotenuse using our shortcut? And here we have the hypotenuse is 20. So how could we find the short leg and how could we find the long leg of this triangle?